Hi class, this is Professor Smith. I am working on Final Exam Review Part 2, number 8, where we're asked to find the partial fraction decomposition. So just in the last example, the first thing that we did was we were to factor the denominator. So I am going to open up math type to capture what I would do if I was using paper and pencil or writing on the board. So to factor our denominator, we notice that each term has an x, so we can factor out an x. And that'll leave us with x times x squared plus 6x plus 9. And then we notice something really cool with our second factor. It is a perfect square trinomial. And they're thinking, wait a moment, how do you know it's a perfect square trinomial? Well, if you take the last term, or the constant term, or the coefficient of the constant term, if there was a y squared there, but in this case we won't have to worry about that. But you take that number 9, and 9 is a perfect square. It's 3 squared. And if you double 3, you get the middle number, 6. That lets us know that we have a perfect square trinomial. And I've expanded it out this way, but I think it's easier to just look at the 9 and say, ooh, it's a perfect square. If I double it, do I get the middle coefficient? Voila! Then it factors. Yes, it does. And it factors into x plus 3 quantity squared. Another way to think of it is if you take 9 and ask what are factors of 9 that add up to 6, you will get 3 and 3. So you get x plus 3, x plus 3. So we're going to write that as x times x plus 3 squared. So anytime we have a factor that repeats itself, there's a different way that we can decompose the partial fraction. So let me show you the rule that we use to decompose that partial fraction. Now I've opened up the rule when we have repeated factors. So suppose that the denominator contains a factor of the form ax plus b, which is a linear factor, raised to the nth power. Then the partial fraction decomposition will contain a sum of n fractions. A1 over ax plus b, and here we have it raised to the first power, and then another factor, ax plus b to the second, plus dot 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 a sub n over ax plus b to the nth power. So if this were to the fifth power, we would expand this out to a fifth term, which would have in the denominator ax plus b to the fifth power. So you have to start with the power that doesn't exist, the ax plus b, but you work your way up to the one that does. So we're going to use that now to rewrite the rational expression. So we'll rewrite it as a over x, that's the first factor, plus b over x plus 3, plus c over x plus 3 squared. We're going to do the same step that we did earlier, which is to multiply both sides by the LCD, which is x times x plus 3 squared. We do that, we will have x times x plus 3 squared times the term on the left, x times x plus 3 squared times all the terms on the right, and I've used the distributive property to distribute that LCD to each term. So each term gets an x times x plus 3 squared. Canceling the common factors, here the complete denominator will cancel on the left-hand side, the x and the x plus 3 quantity squared. With the first term, only the x will cancel. And with the second term, one of the x plus 3 factors will cancel. And for the last term, both of the x plus 3 factors will cancel. That will leave us with negative 18 on the right, on the left. And then a times x plus 3 squared, because the x's cancel, bx times x plus 3, because one of the x plus 3's cancels, and then the cx, because both of the x plus 3 factors cancel. In the last example, in order to solve for the variables, we would let x take on the roots. In other words, what would make this factor 0 and of x plus 3 equaling 0, that would give us a root of -3 or a 0 of -3. And then setting x equal to 0 would give us the other root. So we're going to solve for the variables by substituting in those roots. Notice here I say solve for a and c by letting x equal 0 and x equal -3. I'll come back to why we can't solve for b when we do that. Substituting in x equal to 0 into our expression, we have -18 times a times 3 squared, which gives us 9a. And we see the last two terms will cancel because they both have the 0. So you have a -18 equals 9a. Dividing both sides by 9, we get a equals -2. Now we're going to let x equal -3. Substituting in -3 into the expression, we have -3 plus 3 quantity squared plus b times -3 times the quantity -3 plus 3, and then c times -3. And as we substitute in x equal to -3, we notice the values multiplied by a gives us 0, because 0 squared is 0. And then again, -3 plus 3 is 0 again. So the first two terms are going to cancel. And so we have -18 equals 3c. Pardon me, -3c. Dividing both sides by a -3, we get c equal to +6. So let's discuss again, why is it that we're unable to get b when we let x equal 0 or x equal -3? Well, you can look at the factors multiplied by b, and you can see that x equal to 0 is going to make that term disappear or cancel. And x plus 3, when we let x equal -3, likewise, the second factor will be a 0 and hence cancel. So when you plug in those creatures that make the first root 0 and the second one, it's going to make this middle one in this particular case as well. So that won't work. So plugging in -3 and -3 and 0 won't work. But we can pick another value for x. So let's pick a nice value for x. So again, since x equals 0 and x equals 3 will cancel the middle term, we can let x equal some value other than 0 and -3. And let's try x equal to 1. So when we substitute in 1, we have -18 equals a times 4 squared, which is 16a, b times 4, which is 4b, plus c. Since we know that c is -6 and a was -2, we can solve for c. Plugging in a equal to -2 and c equal to 6. We get -32 plus 6, which gives us -26. Adding a 26 to both sides, we get 8. And 8 is equal to 4b, so b is equal to 2. Rewriting the rational expression with the values for a, b, and c, we have the following. A was -2, so we'll put -2 over x. B was +2, so it's 2 over x plus 3, and then plus 6 over x plus 3 squared. So now let's go out to Alex and input this answer. So now we substitute in those values for a, b, and c and write the expression for our answer, and then we can check. Uh-oh. That's not good. What did I do? Oh, C was 6. Oops. Sorry. I know better. I normally always double check, but it's all good. So let's recheck. I wonder if it'll let you miss it twice. Huh. I'm going to select try another. No, I'm not. I'm going to select explanation and show you that there's another way that you could do this problem. So another way to do it after we factor is to, again, clear the denominators. And then at this step right here, where we substituted in the values for x equal to 0 and x equal to -3, instead we're going to multiply everything out and distribute. Let me make this a little bigger so you can see. And so when we multiply, we'll get ax squared plus 6ax plus 9a plus bx squared plus 3bx plus cx. Then we're going to group all the x terms together. So I have a 6ax, a 3bx, and a cx. So I put all those together, the 6a, the 3b, and the c times x. And then the 9a doesn't have an x multiplied by it, so it's the constant you can think of. And then I have an ax squared and a bx squared. So I have a plus b times x squared. So we've grouped all the like terms together and then factored out the x squared and the x. On the left-hand side, I go, ooh, there is no x squared term. So since there's no x squared term on the left, the coefficient could be thought of as 0x squared. So therefore, a plus b must equal 0. There's also no x term on the left-hand side. So that means that the 6a plus 3b plus c must also equal 0. And then 9a must equal this constant term of -18. And so when we do that, we get 9a equals -18. So we get a equals -2, which is what we got earlier. And then once you get a, you can use the second one. So let me scroll down and show you the three equations that they have. So a plus b equal to 0, 6a plus 3b plus c equal to 0, and 9a equal to -18. A then would be -2, and once you solve for a, you can plug in -2 into this one, and then -2 plus b equals 0, adding a 2 to both sides, you get b equals 2. And then once you know a and b, you can use that third equation to find c. And so you do get the same answers that we got before. All right, so that is another way to do the same problem.